Please open in your learning workbook to page 159. We're now going to solve some ALEKS problems involving variation. Here's the first one. Suppose that the number of cars manufactured at an automobile plant varies jointly as the number of workers and the time they work. If 160 workers can produce 32 cars in 2 hours, find the number of workers that can produce 66 cars in 3 hours. Okay. Just like the last problem, the first thing we need to do is identify what are the variables we're going to use for the quantities in this problem. The first thing we have is the number of cars manufactured at an automobile plant. We're going to call that C for cars. Okay, the next thing we have is the number of workers. And we're going to call that W. W for workers. And the next one is the time they work. We're going to call that T. T for time. Okay, so now we have C, W, and T, and we just have to put them all together in a variation equation. So here we go. Suppose that C varies. So that means we need to start with C equals. Next, make a fraction with K in the numerator. Next, find the LY word for this problem. The LY word is right here, jointly. So jointly means that there's going to be 2 or more things that will all go up in the numerator with the K. What are those 2 or more things? The number of workers, W, and the time they work, T. So put times W times T. That's the only LY word in this problem, which means we have nothing in the denominator, so we'll put a 1 there, and then we'll simplify and get C equals KWT. Okay, this is our variation equation. We're now ready to move on to plug in all of the variables except for K so that we can solve for K. The next sentence says, if 160 workers can produce 32 cars in 2 hours. All right, well, 160 workers, that's W. 160 workers is W, which I've been doing in green. Okay, can produce 32 cars, that's C, which I've been doing in red, in 2 hours, that's T, time. All right, so let's plug those things into our equation. So we have the number of cars is 32 equals K times W, the number of workers is 160 times T, the amount of time, which is 2. Okay, so we get 32 equals 2 times 160 is 320, so we get 320K. We want to get K by itself, so we're going to divide both sides by 320. Okay, we reduce this fraction. This reduces to 1/10. So K equals 1/10. If you prefer to work with decimals, you can use a decimal for this problem because 1/10 is exactly equal to K equals 0.1. If these were not exact equal, then we would need to leave it as a fraction. Okay, so K is equal to 0.1, which means we can now put this in our equation to write an equation that we can use to predict the future. C equals 0.1 WT. So now, if someone gives me 2 of the values of these variables, I can solve for the value of the third, which will be helpful as we now approach this last question. Find the number of workers that can produce 66 cars in 3 hours. Okay, so find the number of workers. We're going to try and solve for W. That can produce 66 cars, so then the C becomes 66. In 3 hours, that's time, so T gets replaced with 3. I get 66 equals 3 times 0.1 is 0.3. So 66 equals 0.3 W. I'm going to divide both sides by the coefficient of the variable, which is 0.3. Notice that that's the number on the right side that I'm dividing by. And I'll pick up my calculator to do this division. 66 divided by 0.3 is 220 equals W. W represents workers. So that means that I need 220 workers if I would like to be able to produce 66 cars in 3 hours.